Hello, everyone. Morgan here. So, we've got to talk about something which might seem strange at first, and that is the pH of a salt solution. Okay? Now, hydrochloric acid, that dissociates fully. That's a strong acid. And because it's fully dissociated, we can pretty much assume that the chloride ion does not react with water. It doesn't pick up hydrogens, because if it did, it would just give them back off again, because it's a strong acid. Now, NaF, if you put it in water, dissociates and gives you F minus ion. And F minus ion will react with water because it's the conjugate of a weak acid, which makes it a relatively strong base. That'll give you HF and OH minus. So a solution of NaF is actually kind of basic. Okay, kind of alkaline. NH4Cl. Now the Cl comes from HCl, so it's not going to react. Same way like the Na plus would come from NaOH, which is a strong base, so it's not going to react. But you do have the NH4 plus, which is the conjugate of a weak acid. So the conjugate of a weak acid, of a weak base, is going to be a slightly stronger acid. So NH4 plus H2O, that's going to give us NH3 and H3O plus. So this would be kind of an acidic solution. Okay? So what we're going to be looking at today will be whether or not a salt solution is acidic, basic, or neutral, and how to determine approximate pH, just whether it's acidic or basic at first. So now, KCl. It comes from the acid HCl, and that's strong. And it comes from the base KOH, and that's strong. So this is a neutral compound because the conjugates are both weak. Now KF comes from HF and KOH. We know the base is strong, but the acid is weak. That means a solution here would actually be basic, because the conjugate of HF, which is a weak acid, is a somewhat stronger base. But if you look at it here, you can kind of shortcut and just realize strong acid, weak acid, or strong base, weak acid, the strong base wins out. It's basic. Now, NH4Br comes from HBr, which is strong, and NH4OH, which is weak, which means this is going to be acidic. We illustrated that up with that equation. HClO4 is a strong acid. KOH is a strong base. That means this is neutral. Now KCN comes from HCN, which is weak, and KOH, which would be strong, so that's going to be basic. Now, we're going to look at a couple that both are weak. So we start off with NH4CN. Okay, that's going to have HCN and NH4OH. Okay, so now we need to figure out the strengths of the conjugate bases, so to speak. So for NH4 plus, we have a Ka up here, 6.3 times 10 to the negative 10th. Okay, that's the NH4 plus. All right. Now for the Cn minus, well, I have a K for HCN, so I can find out using Kw. Okay, 1 second EE negative 14 divided by HCN's Ka, which is 6.3 second EE negative 10th. And that gives me 1.6 times 10 to the negative 5th. So now, that means that the conjugate base of HCN, Cn minus, is stronger as an electrolyte than the conjugate of the NH4OH, which is the NH4 plus. Okay, that means this is going to end up basic. Okay, here acetic acid HC2H3O2 weak, KOH strong, it's basic. Now here we have the ammonium. Okay, so that acid is going to be HC2H3O2 NH4OH. Now the Ka for acetic acid is 1.8 times 10 to the negative fifth, and the Kb, okay, here we can figure that out, all right, and that comes out to be 1.6 times 10 to the negative fifth. Use Kw. Now, those are awfully close together, aren't they? So basically it's neutral, but this is, we'll call it acidic because the Ka is just slightly larger than the Kb. HF is weak, okay, NH4OH is weak. This is 6.3 times 10 to the negative 10th for the Ka, and then the conjugate 1.5 times 10 to the negative 11th. Okay, in this case, now, wow, okay, so this is acidic. They're close. All right. So, what we're going to do is a problem here where we try to figure out what reacts with water and fill in the appropriate case. So if I have LiCN, I have Cn minus reacting with water to give me HCN and OH minus. That's going to be a Kb that I need. Okay, my icebox, pretty straightforward icebox, 0.10, ignore it, 0, 0, minus x plus x plus x, 0.10 minus x, x and x. Kb is x squared over 0.10 minus x equals 1.59 times 10 to the negative fifth. Okay, and that is the Kb for Cn minus. They gave me the Ka. I found it just by using Kw divided by Ka. Okay, now solve that. When I solve that, x equals 0.0013, but I must realize that that's hydroxide, not hydrogen ion. So the POH equals 2.90, and the pH would be 11.10. All right, so why don't you give some of these a try? Go through, see if you can figure out what it's like, okay? And then we'll go back and we'll take a look. All right, so number 8. What's the pH of some 0.250 molar NH4Cl? Well, the NH4 plus reacts with water. Classic icebox, it's got to be a Ka. All right, solve for x, which is H3O plus. I got a pH of 4.92. Leave that there for you for a minute. Okay, number 9. What's the pH of an NaF solution? Same similar setup. F minus plus H2O gives me HF and OH minus. Okay. It's a Kb this time. So that gave me hydroxide. So I converted POH into pH at 8.08. I've got a slightly older version of this lecture outline floating around. If I had 11 questions on the page that you got. Question 9 is actually a repeat. It's just instead of NaF, I did it with Kf. So you get the same answer, actually. And then number 10 for an acetate right there. Okay, folks, that is pages 8 and 9. Hope you're having a good day. This is Morgan, signing off.